Today we're going to be looking at Lesson 8, which is going to show us two separate volume formulas. One of the volume formulas that we're going to see is one that we've used in the past, and one may be newer to us. So if you look at the top of your paper, it gives you two different volume formulas. The first one is the one that you should be familiar with, and that's volume equals length times width times height. We wanted to find the volume of a rectangular prism where we were given the length, width, and height. That's the formula we would use. The other volume formula is taking the area of the base times the height. So this is when we're given the area of the base and then we multiply it by the height. It's kind of actually already doing some of the steps for us. If you think of the base of a rectangular prism, so if we were to look at example 1, the base would be the bottom, or even if we look at it on the top here, which is the same as the bottom, to find the area of that base, what we would be doing is length times width. So really, this step here will already be done for us. So the length times the width is also known as the area of the base. So these two things and this are the same thing, and then we just have to multiply both by the height. Let's look at some examples. So in the first example, from the picture, I'm given my length, my width, and my height. Because I'm given those three dimensions, I'm going to use the first formula. V equals length times width times height. I'm going to plug in the numbers I know. I don't know the volume, so I leave that as V. The length is 15. The width is 1 1/2, and the height is 3. Now, it doesn't really matter which order you put those in because depending upon how you're looking at the rectangular prism, those can be interchangeable. I'm going to rewrite the problem putting all of these as fractions. So 15 is 15 over 1. 1 1/2, remember to change a mixed number into a fraction. You keep the denominator the same. Multiply your denominator and your whole number, so 2 times 1 is 2. And then add on your numerator, so 2 plus 1 is 3. So it becomes 3 halves, and then 3 is just the same as 3 over 1. Now, when multiplying fractions, I can multiply more than two fractions at a time, so I'm going to multiply all three at once. To do that, I just multiply across my numerators and across my denominators. Multiplying across my numerators, I have 15 times 3 times 3. Looking at that, I know 3 times 3 is 9, so I'm just going to do 15 times 9, which is 135. Going across the bottom, I have 1 times 2, which is 2, and 2 times 1, which is 2. So I get 135 over 2, which I can then turn that into a mixed number if I choose to by doing 135 divided by 2. 2 goes into 13 6 times with 1 left over. 2 goes into 15 7 times with 1 left over. So it becomes 67 and 1 over 2, or 1/2. And it's cubic inches whenever we're talking about volume, because it's talking, remember, about how many cubes of a certain size can fit inside the figure. So this would mean I could fit 67 and 1/2 cubic inches inside this figure. Okay, let's look at the next example. If you look at the next example, they're telling us our height, and then they're telling us the area of one of the bases. So they've already done that length times width step for us, and they're writing it in as the area of the base. So because we're given the area of the base and we're given the height, we're going to use the second formula. V equals area of the base times height. There is a reason why we use a capital B here, because it's not saying the base times the height, as in a parallelogram formula. It's saying the area of the base, which is why we use a capital B. So that's why it's important to stick with lowercase letters when you're using regular formulas, because the capitals do have a certain meaning to them. So this is saying the area of the base. So now I'm just going to replace the letters with numbers I know. So I know the area of the base is 23.04 and my height is 20. So to get my volume, I'm just going to multiply those two together. I'm going to go ahead and take out my calculator. And I'm going to do 23.04 times 20, which is 460.8. And again, it's cubic inches. Don't let the square inches here confuse you. Remember, areas are square units. Okay, so that would be my answer. So again, we have two formulas to choose from. It really depends on the information that we are given as to which of the formulas we're going to use. Let's look at the next example. So the next example says the volume of a rectangular prism is 45 cubic units. If the length is 2.5 units and the width is 6 units, what is the height? So this is one of those problems where we're actually given the volume. So if you look at this problem, you can see that there are three dimensions that are being mentioned: length, width, and height. Because we're mentioning three of the dimensions, we're going to want to use that first formula that has the three dimensions listed: length, width, and height. So I'm going to start by writing my formula down. Volume equals length times width times height. And then I'm going to replace the variables with the numbers I know. So it's telling us the volume is 45. So instead of V, I'm going to put 45. The length is 2.5. The width is 6. And as of right now, I don't know the height. My first step in a problem like this is to do any math that I can possibly do. So if you look, we have 2.5 times 6 here. So I'm going to box that in to see that that's what I'm going to do first. I'm going to copy down everything before that box, and then I'm going to do the math. So I'm going to do 2.5 times 6 to get 15. Since I'm multiplying by h, I'm just going to attach the h here. At this point, I have a multiplication algebraic equation. And remember, to solve a multiplication algebraic equation, we're going to use the inverse operation. So the inverse of multiplication is division. So that means I'm going to divide both sides of the equation by the number that's next to the variable, which in this case is 15. These 15s cancel each other out, which leaves me with h. And I will do 45 divided by 15, which is 3. So that means the height is 3 units. Okay, so very similar to problems we've already seen like this year. Okay, so now we'll look at one other example. In this example, it says the volume of a rectangular prism is 47 1/4 cubic units. If the area of the base is 13.5, what is the height? So notice this time we're given the area of the base and height to work with. So that means we want to use the other formula. The volume equals the area of the base times the height. So my next step is going to be to replace the volume with 47 1/4, to replace the area of the base with 13.5, and I'm just going to put that right next to h for height. Once again, we have a multiplication algebraic equation that we're going to solve by dividing both sides by the number that's next to the variable. So in this case, 13.5. These two 13.5s cancel each other out, leaving me with h. When I go to do this problem, I can turn each of these into a decimal if that makes it easier. Remember, to turn a fraction into a decimal, you divide the numerator by the denominator. So I would do 1 divided by 4, which is 0.25. So that becomes 47.25. And I'm dividing that by 13.5, which, if you don't know, is 0.5. Or you could do 1 divided by 2 to get that 0.5. So now in my calculator, what I can do is 47.25 divided by 13.5, and I get 3.5. If I want to turn this back into a fraction to stick with what was originally there, 0.5, same here, is 3 1/2. 3.5 would be fine because it does have the same value though. So this would be 3 1/2 units. Okay, so now you have some problems that you can work on in your Playposit. Good luck!